How an ancient human species formed family ties. Normandy's beaches bear more than memories of D-Day, the 1944 landing of some 130,000 Allied troops in Nazi-occupied France during World War II. Another human species once stalked those grounds. About 80,000 years before World War II, when the shore lay several miles farther out, Neanderthals camped on the dunes of what is now Normandy. Butchering prey, fashioning stone tools, building fires, as the group busied themselves with daily chores, they left hundreds of footprints in the mud. Sand swept over the tracks, which stayed buried for millennia, until 21st-century archaeologists uncovered nearly 600 of the footprints. Based on the size and shape of prints that likely had been laid within a few days, researchers reconstructed a unique snapshot of a Neanderthal community, a few adults accompanied about 10 teens and children, including a 2-year-old. This portrait constitutes just one piece in the larger puzzle of Neanderthal social lives. For decades, researchers could not answer questions like how did Neanderthals choose mates, form communities, and care for one another. But thanks to the Normandy footprints and to new clues from methods such as ancient DNA, the mysteries of Neanderthals' relationships have recently started to resolve. The emerging evidence suggests Neanderthals formed tight-knit communities, but may have been relative introverts, compared to our Homo sapiens ancestors. They lived, cozy, but without parties, as archaeologist Penny Spikins, of the University of York in the UK, puts it. Ancient footprints preserved for 80,000 years on a beach in France paint a picture of a Neanderthal community's members and movements. The species-wide story. In the century and a half since an 1864 paper first described Homo neanderthalensis scientifically, researchers have established the broad strokes of the species' evolutionary history. Based on genetic dating methods, around 600,000 years ago, an ancestral population parted ways. Some members stayed in Africa and evolved into H. sapiens, while others spread north, giving rise to Neanderthals in Europe and Denisovans in Asia. Members of the lineage leading to and including Neanderthals lived roughly 430,000 to 40,000 years ago in environments from Siberia's tundra to the sun-baked beaches of the Mediterranean. Zooming in from the species-wide story, less is known about their communities. The most commonly found remnants from Neanderthals, stone tools and fossils, generally accumulate at a site over centuries, reflecting many past groups rather than only one. Methods like radiocarbon dating provide estimates that can span a couple of thousand years for this time period. Two Neanderthals with similar radiocarbon measurements may have actually lived 2,000 years apart. Researchers can rarely be confident they've found traces from Neanderthals who roamed together. That's why the footprints at Normandy stand out. Uncovered at a site called Le Rosel, the tracks capture a snapshot, a very brief moment of life, says paleoanthropologist Jeremy Deveau of the University of Tübingen in Germany. In a 2019 Science Advances analysis, he and colleagues focused on the 104 best-preserved prints within a vertical thin excavation layer probably accumulated over a few days. Supporting the track's contemporaneity, the researchers enlisted volunteers to stride across similar muddy dune sand and found that steps vanished unless buried within hours or days. While the scientists cannot know whether the full Neanderthal pack was present, what Deveau calls the first picture of social organization, depicts a small group of about a dozen, mostly youngsters. Considering the tracks lay near campfires, stone tools, and animal bones, it seems the young Neanderthals, safe and capable, wandering relatively free and exploring things, says Spikins, who was not involved in the study, contributed to the vital tasks of hunting and crafting. Two Siberian cave sites, Shagarskaya, here, and Okladnikov, provided Neanderthal DNA samples that suggest small communities with low genetic diversity. Close-knit group. Since the footprint study, ancient DNA has strengthened the notion that Neanderthals stuck to small packs, and filled in details about their family ties and mating habits. Decades of genetic analyses already revealed poor species-wide genetic diversity, suggesting the total number of Neanderthals on Earth hovered low. But most of the fossils that yielded genome-wide code came from sites separated by thousands of miles and millennia. These remains, from Neanderthals who never crossed paths, could only hint about the makeup of Neanderthal communities. That changed with a 2022 Nature paper that reported DNA from Shagarskaya and Okladnikov, two Siberian caves separated by just about 50 miles where Neanderthals camped roughly 50,000 years ago. If we were ever to find a Neanderthal community, this would probably be where, says study author Lorit Skov, a geneticist now at the University of California, Berkeley. The work was challenging, in part, because acid from goat poop and from the digestive systems of hyenas chowing down on the bones had obliterated much of the fossil DNA. Nevertheless, Skov and colleagues reconstructed genomes from probably 6 adult and 7 younger individuals between ages 3 and 20. Specifically within Shagarskaya, some folks might have been cousins. Another pair, sharing a quarter of their DNA, could have been aunt and nephew. An adult father and his teenage daughter were identified. Even non-relatives shared tracts of DNA, which suggests the community had been small for upwards of 10 generations. This low level of genetic diversity is similar to that of present-day mountain gorillas, who live in groups of 4 to 20 individuals. It also appears these Neanderthals followed rules or traditions for choosing mates. Males stayed with their birth group while females ventured off and joined new kin. That's based on the fact that the male-inherited Y chromosomes were far less diverse than the mitochondrial DNA, a small loop of code passed down the maternal line. Shanidar 1 shows deformities that may have caused visual and hearing impairment, suggesting the community supported him, while burials like WWII 2, here, a 2-year-old, demonstrate the care taken with children's interment. Safety and comfort. The Neanderthal genetic results differ starkly from H. sapiens patterns, and might indicate fundamentally different social needs between these two human species. Compiled in a 2011 science paper, genealogical studies of 3,067 individuals from 24 contemporary forager societies showed hunter-gatherers typically live in bands averaging about 30 members, including unrelated individuals with no blood or marriage ties. Often, members of any sex can leave or stay with their birth group. And most distinct from Neanderthal ways implied by their genetics, these bands of a few dozen members have ties with other such communities, forming wider societies with hundreds of people. The scattered groups meet up for trade, marriages, celebrations, and more. These social habits seem to extend back to Stone Age H. sapiens. In a 2017 science study, researchers analyzed genomes from 34,000-year-old graves at the site of Sungir in Russia, about 120 miles east of Moscow. 2 children, an adult male, and an isolated thigh bone from a female, these people buried close together were not close kin. Unlike the analyzed Neanderthals, their genetically distinct DNA suggests the Sungir humans belonged to a larger society of 200 to 500 potential mates. In her 2022 book, Hidden Depths, The Origin of Human Connection, Spikins proposes how these social differences might play out behaviorally and arise biologically. To make sense of Neanderthal sapiens distinctions, she draws from research on other closely related species. For example, compared to free-ranging dogs, wolves more willingly hunt collaboratively and share food with their packs, made of mostly blood relatives. And although dogs eschew sharing, they more readily form new packs with non-relatives. At a biological level, these proclivities relate to differences in hormones including cortisol, dopamine, and oxytocin that influence one's stress levels, eagerness for new experiences, and emotional bonds. According to Spikins' idea, differences in hormones and their underlying genes may have turned Neanderthals into relative introverts and H. sapiens into novelty-seeking extroverts. A lot of us find it a little bit anxiety-producing meeting strangers. Neanderthals might find that very much more anxiety-producing, she says. That's not to say Neanderthals never assembled. In a 2023 Science Advances paper, archaeologists reported thousands of butchered elephant bones, which belonged to an extinct species nearly doubled the size of modern African elephants. The researchers estimate meat from one could have fed 350 people for a week, and the site held more than 70 elephants killed over a 300-year span in what is now Germany. The results suggest bigger groups of Neanderthals formed, at least to hunt these mega-elephants. But the seemingly more typical insular groups surely offered some advantages to Neanderthals as they braved the wilds of Ice Age Eurasia. Based on studies that estimate energy demands, moving across the landscape would have burned more calories for short, husky Neanderthals than long-limbed H. sapiens. Traveling far to fraternize might have cost too much energy. Spikins also suspects small communities provided safety and comfort for more vulnerable members. In a 2018 World Archaeology paper, she reviews fossils of Neanderthals with skeletal markers attesting they lived to old age or through serious injuries. The list includes Shanidar I, a middle-aged male Neanderthal discovered in a cave of Iraq. The individual's leg and foot had fractures that may have caused a persistent limp. Vision impairment or even blindness is suggested by a healed blow near the left eye. And he suffered hearing loss based on deformities in the skull surrounding his ear, according to a 2017 PLOS-1 study. Community members must have provided food and support to Shanidar I, Spikins and other researchers contend. People were being looked after who clearly weren't going to get better, says Spikins. There must have been the emotional motivation to care. By some counts, all nearly complete skeletons of Neanderthal adults show signs of at least one healed broken bone. Children, too, seem to have received special love and care in Neanderthal societies. Despite the fact that tiny bones decompose more easily, children under 4 years old make up more than a third of the few dozen Neanderthal burials ever discovered, by Spikins' estimate in a 2014 study. For these wee skeletons to have survived, Neanderthals must have carefully interred the lost children. Meanwhile, archaeologists have only found 2 total child burials from H. sapiens more than 60,000 years old. A Neanderthal child might grow up knowing a very small set of relatives, and that's actually probably quite cozy, says Spikins. But cozy brought a major biological downside. Inbreeding appears to have been common in Neanderthal communities. Repeatedly, genetic studies have detected individuals whose 2 copies of the genome, one from each parent, harbor long stretches of nearly identical DNA, which results from sex between close family members. This pattern has been detected in the physical appearance of bones too. Examining remains from Spain's El Sidrón cave, anthropologists in 2019 reported at least 4 Neanderthals with deformities probably caused by inbreeding, including poorly formed vertebrae and a misshapen kneecap. Research on inbred modern human groups has shown the practice increases the risk of genetic disorders, and decreases one's chances of survival. The accumulating evidence paints Neanderthal communities as small, insular, and often inbred. Perhaps their aversion to new mates ultimately pushed Neanderthals from endangered to extinct.